Thanks. And similarly for low-level design, like when I went, unfortunately, I was not able to attend the last class, but I went through the recording and understood that you have you have told that about an approach like class diagram, entity diagram, and then the activity diagram.
Yes,
So
yes.
is there a structure for that? I mean, like, can you tell that structure once again so that I can take notes on that?
Sure, sure. We'll cover that also, right? The structure for low-level design. But yes, see, the concepts are important. Structure, we also followed in the tiny URL. So as we will be solving more and more problem, this will become clear. But yes, what you should understand is first is understanding the question. What is the problem? We should have a good understanding of the question and problem. You should clarify the requirements. This is both for low-level design and high-level design. Understand the requirement. And then once you are clear with the requirements, you have to focus on first few requirements. And you can then ask the expectation of the interviewer and also clarify the non-functional requirements. Once you are clear with functional and non-functional requirements, now drive the discussion. As an architect, you have to drive the discussion. You have to go ahead and design the systems. Maybe for designing the system, first you will make some assumptions. And with assumptions, you may do some, for high-level design questions, you may do some back of the envelope calculations. And then followed by system design, component design. And you start with a high-level design. Overall, go with the top-down approach. And then design the system as a complete. And then explain and justify what were your design decisions all about. For low-level design, after you have the functional requirement, non-functional requirements are mostly clear because clean code, maintainability, extensibility, understandability, these are the requirements for low-level design, non-functional requirements. Then after you are done, you can start drawing use case diagram to share that you have a good understanding of use case diagram. Because now here in low-level design, what is important? You should follow object-oriented modeling of any application. So in object-oriented modeling, you start with use case diagram. Either you draw the use case diagram or you write the use cases. Once you have written the use cases, you will be able to identify the entities or classes. So you draw the class diagram. In object-oriented programming, what is very important is encapsulation. You have to identify the data and behavior, and you put them into the classes. I also covered last time the principle of abstraction, data hiding. So you apply all these concepts and you start by designing a class. Class will have the attributes and methods which you operate on. And then once you have the class diagram, you may also proceed with database design. Figure out what things you will be storing in the database. And then for each of the methods, you may start with doing the sequence diagram. So this way you will have the sequence diagram. You may draw a sequence diagram or activity diagram or flow chart, whichever you are convenient with. So this covers your low-level design. So if you are not comfortable with any of these diagrams, then you may also write a pseudocode or a code in some programming language of some of the methods so that you share that you have complete end-to-end understanding and you can design a system from modeling the classes to the implementation of the methods. So this is the approach for dealing with low-level design.
Okay, then thanks.
Great. So, yes. So I've shared all these notes. I have refined these notes, maybe made it more easy to understand so that you can go through it. I have divided, last time we covered many concepts. So the first concept which we covered was about object-oriented concepts. We covered what are classes, what are interfaces, what is encapsulation, what is data hiding, what is abstraction. And we also had some funny examples, right, of an employee and number of hairs and yes, t-shirt color. So demonstrated the concept of encapsulation, abstraction. We also discussed polymorphism and programming to interfaces. What are the benefits of this? I gave this example of a bulb with a filament, the old kind of bulb which we don't see nowadays. But yes, there is another bulb, CFL kind of bulb. Yeah, that also we don't see these days. But yes, the interface is always there. We see it's is still intact. So yes, we also discussed about polymorphism, giving that, okay, there could be different implementation, but yes, based on the object, you may have different implementation. We also discussed about method overloading and method overriding. So these were the object-oriented concepts we studied. There are more object-oriented concepts which we will be covering today. And we will be going to design patterns and many other advanced concepts. So coming to the advanced concepts, I discussed about overloading, which is a static polymorphism, overriding, which is dynamic polymorphism. So I have shared the code example as well with the snippet. This is in Java. You may use it. You may convert it in C++ and Python, right? So people who are Python programmers, maybe if they can share the same examples to me over email, that would be, I would highly appreciate it. I'll put this in the notes so that for everyone, they can see. Someone who is C# developer, he may also share examples for static polymorphism and dynamic programming, dynamic polymorphism. So yes, this is about overloading and overriding. In addition to this, we also discussed one more important concept, which is about cohesion and coupling, right? So I shared what I mean by loose coupling and what is high cohesion and what is desirable, right? So yeah, we also discussed about inheritance, different kinds of inheritance. And in inheritance, the drawback is a coupling. So we discussed this in depth, and we also discussed the example of programming to interface, and that also demonstrate polymorphism, right? So these are various topics which we cover. So these notes are available to all of you, right? So yes, now who all attempted the design of chess, design of online game chess? Anyone would like to share his design? Because we were halfway through the design exercise. because we also discussed halfway through the design of chess, online chess game, which can be played by multiple users. So I asked you to take it as a assignment to complete this part so that you get a practice. See, practicing is very important because again, no system design, it looks like, okay, you may be able to do it because if you are understanding things in the class, this is just the beginning. Very important thing is you should be able to do the same in the interview when there is a time limit and when there is a person who is continuously evaluating you. So under pressure and under nervousness, you should be able to still demonstrate and work and should be able to complete the system design, which is low level design or high level design. Okay, let me just try getting the low level design of the chess, and then we will cover remaining concepts. So just give me a minute. I'm getting these. I'm getting the design which we had last time. Yes, so this was just a minute. Okay. So we were designing this chess game. So we designed the classes, right? So we did not design the various relationship between the classes, but we did design the classes and their methods for few of them and for behaviors of few of them. For example, move class we defined, right? Some other inheritance we defined. Yeah, there was few relationships which was defined, which is pieces, pawn, rook, and knight. Yes. So let's leave it from here. I'll give you more time to kind of complete this. So we completed the use case diagram. For who all are wondering what is use case diagram, these are the diagram which represent actors and the system and what are the various use cases, right? So in this use case diagram, we had a chess engine. Chess engine will validate the moves. It will end the game. It will match players, or they will be it will identify the players who have the same skills, and they will be put in a game. Players could be two types. There could be a white player or a black player. Person who will start with white pieces, he will be the first to start the game. And a player may invite friends, may create account, may do profile management. These are all simple functionality, standard functionality. But what is important here is a player will start a game and he will make moves. So that is what the actor is, how actor is interacting with the system. So this was all about the chess. I will give you more design, more time to think about the design, and go ahead with more detailing of the design, right? So because it's very important that you guys by yourself do these designing. Okay. So let's now, what I would do is I will cover some of the concepts which I did not covered last time. There are very important concepts which will be required to design the chess game, right? So let me share a few of the concepts. I'll ask you to elaborate on and tell me what these concepts are, right? So very important thing, tell me about this is, yeah. Okay, so the concept which we will be covering is, let's talk about, actually this is coming in my way. Let's talk about one concept, which is association. Right? Who will tell what is association? Anyone who can tell what is association? Yeah, association is a relationship between two or more objects. Okay, association involves tight coupling or loose coupling. Who will tell? Use the chat message. Are you using chat messages? Because I'm not seeing any chat message today. So yes, tell me what is association? It involves loose coupling or tight coupling. So association is a relationship between two entities. We have different kinds of association. So let me draw this. Yes. So let me get the classes. So I have a class here. And in our case, we have a class. And let's say we have this class, which is employee class, right? So for employee class, employee is associated with whom? Employee is associated with
company
projects, right? So yes, when I put projects here, what kind of association it is? And how will you model this? So anyone, what is the kind of association between employees and projects? Basically, we will use all singular name in the class name. So this is the class. You have employee name, employee we discussed. We have the properties. for employee, which is various properties, which will be name, it will be ID, and other details that could be salary. It could be some, yes, employees assigned to one or many project. Yes, absolutely right. How would you show assignment?
I didn't catch that. Could you try again?
Okay, sorry. There was a doubt from Siri in my computer. I don't know how it got activated, but yes. So yeah, employee is associated with project. So yeah, how is this association created? This is my question. Yes. In the code, how will you depict that? Okay, employee is working on a project. Project has some attributes, which is project ID. Maybe project will also have name. We can call it project name. Right. And I will also put here project ID. And how will you associate that employee is working on a project? So employees can work on how many projects? Employees can work on multiple projects. You should understand this. This is a very important thing, that employees can work on multiple projects, and a project may have multiple employees. Project can also have multiple employees. So this association is many-to-many association. Yes, so we will depict it by putting star. So a project may have 0 employees, or project may have any number of employees. And at this same time, an employee may be assigned to 0 project, like he's in bench. Yeah, that's the best scenario. For an employee, he can devote all his time in learning new things, or maybe learning system design, learning data structures if someone is in bench, and then can crack Google, Amazon, Microsoft, Facebook, or multiple offers, right? So I still wonder why people complain when they are on bench, right? So, but yes, no, not jokes apart, but yeah, coming to here. So a project may have many employees. That means the work has started, or project may just be planned and might not have started. So that means there are no employees in that project. So this is many-to-many relationship. Yes. So for modeling many-to-many relationship, you may need another. Yeah, so this is many-to-many relationship. So yes, for employee, if we have to denote that, okay, he's working in some projects, what I can do is I can create a list, right? Or an array. Yes, generally array is project. So which we can say, I can name it assigned projects, right? So this is a list of projects. Yes. Correct. Same on the other side. For project, I may have a list, but here I can say assigned employees. Right. So here I have employee, and here I could say assigned employees. Yes. So I'm able to model this, right?
Yeah. Sarun, sorry to interrupt in between. Basically, I joined just now because I was having a call. So
Yes.
So just want to check like what we are kind of currently discussing so that I can actually.
Yes, right. So can anyone tell what we are discussing?
Relationships.
No, we are not discussing relationships. Yes.
Please give me a little bit more information. Otherwise, I'll
Yes,
think something
no, we
else.
are not discussing relationships. It's an
Association.
object-oriented principle, right? There is no such principle of relationship in object-oriented programming. Very close answer, but not the exact answer, right? We are discussing what? Anyone else?
Association relationship, right?
Yeah, associations. We are discussing associations. Yeah. So employee is associated to project.
Arun, for association,
Yes.
there should not be that head, right? In that line. It should not that line is pointing from employee to project, right?
Yes.
But
Yes.
that head should not be there, right?
Yeah, basically
Indication.
here, yes, here there is no, this is possible, right? So you may denote like this, right? So basically there are two associations. Employee is associated with project and project is associated with employee. Yeah.
So Tarun,
Yes, you are
we-
right. As per UML diagram, you should not have, it should be a straight line, right? Got it.
Tarun, just want to check, basically like previously, I think we have left with chess, right? So we were designing low level
Yes.
design on chess.
Yes,
So
yes.
are we done with that, or we'll be doing later on?
The chess was an assignment I asked you to do at home.
Right.
Right. So I will be revisiting. I have given you more time to do that. So we'll be covering it. But yes, before that, you have to apply various concepts in chess also.
Right.
So I'm covering concepts. One is
Okay.
association. Yes.
Right. Yeah.
Next is. So yes, very nice suggestion that yes, as per UML convention, this arrow is not required because in UML, arrow is generally used in inheritance, right? But association is just a straight line without any arrow head. Yes, right. Absolutely right. So let me see if I can remove it. Yes. Right. In this, I got it removed. But somehow, yeah. Just assume there is no such arrowhead. Yes. Somehow, yeah, I need to hide it. But yes, let's see. I'll figure it out how to hide that. But yes, don't worry about that. Assume that
There is delete button, like click in the actions, you can delete it.
okay.
Left side, middle.
Left
Under
side.
actions, bottom.
Actions, I delete.
Yeah.
So the line is gone, right? Not the arrow.
We can draw the straight
Yeah,
line.
I will draw a new one. Okay, good. Yes, nice suggestion. So yes, as per UML convention, just having the line is good enough. No need to have associations, right? And then employee, we said probably employee will implement an interface, which is we discussed last time that this interface, we can call it as workable interface, right? So whoever is working in workable, whoever is having this interface implemented will be able to work, right? So there will be many methods also, calculate salary or fill timesheet, and there could be many other methods. So based on what is the use case we are working, we have to decide what all methods are there. But yes, here what I wanted to show is, assume this workable interface is, actually workable employees implement workable interface. So there is a inheritance here. So this you have to depict using arrow. So what you do is you depict it like this, right? This is the triangle arrow which is used. So yeah, there are different kinds of arrowheads available here. So I should use the right one. Yes. So
Is a relationship, right? Is a relationship between employee and worker.
yes, this is the is a relationship. Absolutely. Right. So this is the arrowhead which I should use here. Yes. So this is for inheritance and this is the association. So this is difference between inheritance and association. Okay. Now let me also implement or let me also put one more class. Let's call this class departments. Right.
Workable is interface, right?
Yes, workable is a interface.
Then it should be generalization, right? Not interface. If if it is
Yes.
a concrete class and if something is extending, then it should be inheritance, right?
Yes, yes. And this, what is the symbol you would suggest here?
Uh, dot lines with arrow.
Dotted line. Okay, okay. Sure, sure. Yes, you guys are good. But yes, I don't have that. But yes, this is fine. Doesn't worry. Don't worry about that much of detail because the concept is important. So dotted line, yes, you could use. But yes, you should also understand this is also inheritance or but yes, you are right. Is not a is a relationship. But yes, this is good point. It is implements, right? Relationship.
Hello, sir.
Okay, okay, good. So let's go to the department class, right? Now, what I wanted to also make you understand is another type of relationship, which is called aggregation, right? So what is aggregation? There is few other concepts. One, I will say aggregation. Other, I would say composition, right? So these are the two concepts we need to understand. So yes, Arun, you have any idea about what is aggregation?
Aggregation, if there are two classes, A has like A class and B class, and A has instance of B, and B can exist without worrying about A.
Right, right. Yes, this is aggregation. Aggregation is the relationship. So for example, employees and departments. What is the kind of relationship? Can an employee be there without a department? Again, right? I'd assume, yeah, you can assume something like, yes, an employee could be hired and later could be assigned a department. So employee can exist without a department, right? And also a department can also exist without employees. Maybe I created the department and I'm yet to hire people for that department. Yes. Right. So what kind of relationship is this? It is an aggregation relationship. Yes. So let me put here name and right. So department is aggregation of employees. Can we say that? Now I should use the right symbol. So yes, we have these arrows also. So you have what kind of relationship? Employee to department. Can an employee be in many departments? No, it cannot. He cannot be. Employee should be assigned to either 0 or 1 department. Can a department have many employees? Yes, it can have many employees. Right. So this is the relationship which you have to model. So let me see if I get some symbol. No, this is not the right symbol, but yes, I should get a symbol for this. Yeah, I actually, this is a many-to-many symbol. I can place it here between project and employees. But yes, between the other, I'm not getting the symbol, so I'll place a line here. So, yes. Here, this is the relationship. This is kind of aggregation. Now, composition. Let's say, what is composition? Okay, any example you can give about composition? No one knows about composition? A class could be composed of multiple.
Like, yeah. Like, for example, employee has address. So address, right? Has a relationship is a composition, I can say.
Yes.
So let's suppose there is a relationship between employee, right? Employee will have address, or maybe let's suppose company.
Yes.
Right.
Yes. Okay. Nice example. Yes, I'll take this example. Yes, good suggestion. So you have an address, right? So here, address is a assume class, but yes, actually it's not a class. But yes, we can consider it for sake of just, it's up to us how to model. We are the architects. But assume we design a class address, right? And address has many other fields also. For example, address will have so address has many other fields. So for example, address would have, say, the flat number, right? Address will have maybe your area, your city, right? And state, PIN number, country. So it has many attributes. So address is an entity, no doubt about it. And address is also associated to employee because employee has address, correct? Now, employee and department can exist independently, but address cannot exist independently because you don't need to store any address just for the sake of storing an address. If the employee is there, then only you will store the address. If employee resigns and you delete the employee, you will also delete the address, correct? Because then no need to store the address. But if an employee resigns, you will not delete department because department may still exist. If all the employees, assume there was a bad manager, all the employees in the department resigned, even manager also left after that, still the department details you will keep. Yeah, maybe you will hire new employees, but yes, there is a difference between aggregation and composition. So this is the difference between aggregation and composition. Correct? So first one is when I am saying this is aggregation, right? And this one is composition. So you should understand here the importance, because in composition, the life cycle is tightly coupled. In aggregation, life cycle is not tightly coupled, right? But yeah, relationship is same. An employee may have many addresses. That's also possible. He may have a home address, office address, permanent address. So there could be multiple address of employee. And you may have, a lot of bachelors staying in the same apartment, working for the same company. So multiple employees may have the same address also, right? So this is also many-to-many relationship. correct? Like, yes, employee project, this could also be many to many. So you have to ensure while modeling, what is the cardinality of the relationship? What kind of relationship is it? Is it composition, aggregation, or it could be simple association, right? Employee in project is not aggregation, it is not composition, it is association. Because you can't say employee is composed of projects or projects are composed of employees, right? So you have here all three kinds of relationship.
So how can we
And I
implement
showed
all
also
this?
inheritance. Inheritance also another example I will also show. Let's say we have a person class. Yeah, just give me a minute. So we have a person class. So yes. So person employee will inherit all the properties of a person, right? So let me again use this same yes, arrow. Now I got the arrow and I'll point it. Yes. Right. So now employee is a person. This is a relationship. Yes. So you have here is a relationship. Now, important concepts here are specialization and generalization. These are two more things you should understand. Yes. Someone was asking some questions. Anyone having any questions? Anyone wants to describe what is specialization, what is generalization?
So like the composition and aggregation, how can we implement? For us, for association, we will be having this list of objects. But for aggregation, how can we do in the class level?
Yeah, you will also have a list of objects, right? List or variable, depending on what is the cardinality. If it's one-to-one relationship, you will just have a variable, right? Otherwise, it could be a set or list. It's up to you to choose the data structure which is appropriate. But yes, you have to ensure that in case of composition, you manage the life cycle. Basically, what will happen is, let's go into the coding part, right? So this is good question actually, because it helps me to cover one more concept, which is we'll cover, because see, these are all foundations of design patterns, right? So now when I am creating an employee, I will also create a new address for employee. You see here, I'm writing some code, right? Let me put this big. So this is the address for employee, right? So let's say this is constructor of employee. I have a class employee, right? And within this, I have various properties, but within the constructor of employee, I have here properties like say string name. I will have address class, address, right? Here, see, this is my constructor. So in constructor, I'm creating a new address. Yes. So if you have in C++, you will also ensure that you write a destructor. And when employee is destroyed, address is also destroyed. In Java or C#, what you will take care is once employee is deleted, the address will also get garbage collected. Yes. So yes, you have to ensure that life cycle, which is the creation and deletion of the employee, is controlled by the entity which is enclosing the entity which is composed of, right? Now it's clear how to implement it. This is
Yes.
how I implemented employee and address association. Now, if you say, okay, employees can have multiple address, so I can say that then I'll have a list of address. Yes, here, multiple addresses could be there. Yes. So in that case, I will have to create multiple addresses and assign it. Yes. So here I'll have to take care of creating a list rather than just creating a one object. Yes. So you have to manage accordingly. So this is how you will implement in code association, aggregation, and composition, right? In aggregation, you don't have to worry about this because they can be created and destroyed independently, like employee department. But yes, when you take care of this, it becomes composition. Right. So
Tarun, employee and address relationship is composition, right?
yes.
When there is a composition, we will call that, we will instantiate that in the constructor.
Yes.
Okay. When there is aggregation, and I'm not fully understanding the aggregation relationship between employee and department, because employee has to be in one of the departments, and department contains the employees.
Yes.
Both are dependent on each other, right? So is the aggregation
Okay,
relationship?
nice. Yes. So you have here probably how you will model, right? You will have a department here, right? And you may have a list of employees in that department.
This is association, right?
Is aggregation. Yeah, aggregation is also a kind of association. Right? Everything we are talking about are association. They are different kinds of association.
So
composition,
aggregation is,
yeah.
aggregation means if A and B classes are there, A depends on B, but B can exist without A, right?
Yes.
So,
yes.
but the department cannot exist without the employees.
Can exist. I gave an example. See, you guys are not listening. I said all the employees left the company. Will you delete the department also? Department will still remain. You will hire new employees. Yes. So that's why it's aggregation. Because you will not delete the department. Department will always exist. Department can exist without employees or with employees. Both. They are totally independent. Domain knowledge is important when you are modeling the relationships or associations, right? So you need to know HR details. So HR will be able to tell very correctly, oh, this is composition, this is association, this is aggregation, because here we are kind of modeling the organizational structure, or this is something related to HR, right? So you have to be very careful in understanding the domain. Now, is it clear that employees and department can exist independently? You do not have to create employees within department. Yeah, maybe if you create a new company, you may decide your business rules. You may say that, okay, I will create a department and employees will only exist if department exists. If department is removed, automatically all the employees will be removed. In that case, department is a composition. No, department is a composition of employees in that case.
Okay. Then like
But
how to
here,
differentiate?
department is aggregation of employees because it's just, many employees are there in department, but both of them can exist independently, right? Employee, even if your department is gone, employee will remain, right? Employee may be assigned to some other department.
Here association and aggregation. You told aggregation is a type of association, right?
Yes, yes.
How to differentiate between these two? Which type of relationship I have to keep?
Yes. Right. A driver drives a car. Right. There is an association, driver and car. But you cannot say car is composed of driver. Driver is an independent entity. Car is an independent entity. So the next topic, which is message passing. Right. So if two entities are communicating with each other, they does not, then there is an association between these two. Right?
Without
So
hard dependency.
there is, no need to have hard dependency. Yes, absolutely. Absolutely right. So some associations can also happen when you have parameter passing. So message communication is nothing. Two objects, they communicate with each other by calling their methods, right? So when they invoke the method, their communication between the objects happen.
Yeah, communication is everywhere, right? In aggregation, composition, and association. That is common, but
Yes.
Based on the communication, how can so not fully differentiating association and aggregation.
Yes, right.
What I am thinking is like association, there is relationship, but both can exist independently. Aggregation, one has hard dependency, other can exist independently.
Yes, right. Family is composed of members, right? But there is also association with you and some neighbor. Neighbor is a association, right? So maybe some methods are there, like in case the neighbor is not there, you take the courier. That could be one association, right? Or another association, if he parks the vehicle in your slot, you fight with it. That is another association, right? But yes, you can't say the neighbor is composed of employee or member, or neighbor is an aggregation of member. These are all different kinds of relationship. Yes. So there is a relationship which is which is inheritance. And that is, there are two kinds of concepts in inheritance. One is a specialization and generalization. So these are all concepts which are for modeling, right? So these are object-oriented concepts. With practice, it will become clear. So yeah, I understand, because it's very hard. Because if you have not modeled a lot of projects or have not applied it, it becomes hard to understand. But don't worry. Just remember that aggregation is something which is, as the name, English name suggests, the meaning of aggregation is collection, right? So aggregation is just a collection. Now, composition is also a collection, but composition is a collection in which the child object is totally dependent on the parent object. It cannot exist without parent object, but in aggregation, parent objects and child objects can coexist, right? So this is difference between composition and aggregation. Association is any relationship between two objects is association. It can be composition, it can be aggregation, it can be something else also. Like, right? So, like I gave an example, funny example. Don't take it on yourself. I'm not saying you guys are fighting with your neighbors, but yes, the relationship between you and neighbor is a association. It cannot be called that composition or aggregation, right? And when you pass message, right, there is a communication happening between two entities. So wherever there is communication required between two entities, you have an association. Okay.
Tarun, in the employee class, this address is a composition, right?
Yes, yes. Employee
And
is, yes, employee entity is composed of address, right?
okay. So yeah, so address. So when we handle composition, we are supposed to handle the life cycle, correct? But let's say when employees deleted it let's say in case of Java, it automatically collect garbage collection just for the the member variables also, correct? And
Yes.
plus, let's say there is a department. Say let's say department is an aggregation here. So, but department also needs to be taken care in the life cycle perspective, right?
Yes, yes. So up to you. If you want to make it composition, if department is removed, fire the employees. Yeah, that is your composition. Another another kind of relationship is department is aggregation. So yeah, maybe give an example of FANG companies. Department and employees are composition. Give an example of TCS or some other good company. Department goes, employees still remain. They can be transferred to other department. So in this second case, when you have a good company, no employee friendly company, you have relationship which is aggregation. But yes, if the company is not employee friendly, then you have composition. That yes, they only create employees when there is a department. When department there, employees are also gone, right? Understood? So you can have both kind of modeling. That's why I was saying domain knowledge is important here. You should understand the domain. So this is nothing to do with C++, Java or anything related to computer science. This is related to the HR policy. Check with the HR what kind of relationship you want to have. Aggregation or composition, they will be able to give you the insight. So talking to stakeholders is very important in object-oriented modeling, right? So in your case, if you are in a system design interview, check with the interviewer what kind of relationship is there, but showcase your understanding of that you understand what is composition, what is aggregation, what is association, what is inheritance, what is specialization, what is generalization, right? So now next thing is employee is a person, correct? Is it aggregation? No. Right? Employee is a person, is a relationship is there. So this is employee is a specialized form of person, correct? Because not all persons are employee, but some persons can be employee. So there is a specialization here. Person is a generalized form of employee, right? So that is specialization and generalization. So when you move up the hierarchy, it's generalization. When you move down the hierarchy, in inheritance, it is specialization. So why I call employees a specialization? Because employee will have more methods than the person class, right? And generalization, because in person will have less methods, but yes, it will have the core methods of employees. So this is all the concepts which are related to object-oriented programming. And these are all part of, there is something called object-oriented analysis and design, right? So you guys have to, this is a very thorough subject. It needs a lot of practice. So you need to practice solving multiple projects, then only you will understand this.
Tarun, got one more doubt. Let's take the case of employee and project. So let's take the case of employee and department. You told that, let's say all the employees are gone out of the department, still the department remains, correct? So that can be applied to project also, right? Let's say a project initially gets created and the employees get assigned to it, right? So how can you differentiate that? I mean, in the relationship perspective, the project and department. The project can also exist without employees. Same like department can also exist without employees. So I've got a confusion there.
Yeah, so you want to make project also aggregation or composition? You want to say project is composed of employees? Doesn't sound logical, right? Project is itself another entity, right? So yeah, you can say that department is composed of employees, sounds logical. Class consists of students, sounds logical, right? Or, but yes, project and employees,
See, then why
don't
we are
call
having,
it in literally the composition or aggregation. You will call association.
if
But
that
yes,
is not
all are
applicable,
form
then-
of aggregation, all are forms of association only. Yes. Can we say project is composed of employees or project is an aggregation of employees? If you say this to your English teacher, right, she will not give you English marks in English. Yes. So in the real world, object-oriented design is close to real world. So yes, you don't have to think in terms of computer, you also have to think in terms of human understanding, right? General domain understanding. So that's why it is very maintainable. Object-oriented design makes things maintainable because business stakeholders can also understand it and technical stakeholders can also understand it, right? And they can communicate with each other using the same language. But yes, when you say project is composed of employees, you are saying correct in terms of computer science. But in terms of normal day-to-day language, or if you are talking to say some HR person, and if you say project is an aggregation of employees or project is a composition of employees, they will not understand it. They will say, yes, you have gone crazy because you say team is a group of players, or you say, no, there is always kind of group connection, but project is not a group. It is some work, right? So that's why we call it association. Got it? But yeah, all are forms of association. You can interchange it, but yes, you have to ensure that should be understandable, right? Because if it works, then it's fine, because main goal is your application or software should work as expected. You can model anyway, right? You can say that, okay, address is a collection of employees. Again, will not sound well, right? Because you may say, okay, in one apartment, there are multiple employees that is staying, but you will not say that address is a collection of employees. Because again, if you talk like that with business stakeholders, then they will not understand you. And they then, yes. So that's why object-oriented design, you have to make it look like real world relationships and associations, right? Then it will become maintainable, because otherwise you have to explain to all the employees that yes, address is a composition of employees. But we are saying the other way around here, right? Employee is composition of addresses, which is right, because employees can contain, employee data contains a lot of fields. It contains address, it contains many other properties, right? But not the other way around. Although there is possibility of relationships in the other way around. Don't worry if you are not understanding it. When we will be doing more exercises, it will become clear, because it will need practice. Right? So model more examples, then you will understand it. So I will move on to the next topic. Is it fine or not? This is confusing, right? But at least you understand what is the definition of all three, which is good. How to apply when and where will come with practice. How many of you understood all these concepts? Say yes in the chat. Who do not understood, say no in the chat, so that I'll make a note and I'll ensure each and every one of you understand it. Okay, good. I see few people have understood. Okay. Okay. I'll ask the questions also. Okay. Nivin do not understood. Okay. Okay. Yeah, there's only yes or not fully is also not understanding. Yes. Okay. Okay. Yeah, but understanding definitions also is not sufficient. You should apply, you should be able to apply it. Now, many people will say, oh, no, I also do not understand fully polymorphism. I also do not understand fully the concept of classes and objects. Because yes, applying it, or if I see the code of many experienced people, I can still say that these guys don't understand association, composition. Sometimes people do not understand inheritance. Sometimes people do not understand interfaces. Sometimes people do not understand basic concepts like abstract classes and all. They understand the definitions, but when they apply in the project, they really make a mess out of it. That's why we have so complicated codes, right? But if everyone applies these principles well, the software development would have been very good experience for all the developers, right? But yes, because of these only, they model different ways, and then they have to make people read documentation to understand what is what. Yes. So try to make things which is very realistic and understandable. But yes, do not worry. You are not the only ones who are not understanding these principles, but these principles are important. And if you understand it, you will only understand after applying it multiple times. Yes. Okay. Now let me move to the next topics, right? So I will share you the definitions, right? So I have the definition here. So, but yes, understanding how to apply it is very important. Is the only thing you should understand. Definition, if you forget, no problem. But how to apply it, you should not forget. Now let's talk about another important concepts. We have a lot of concepts to cover, because I know if we don't get all these concepts well in interview, the possibility is it's not solid, it's solid principle. So we'll understand the solid design principle. This is another good concept which we should know.
And I think that is very important. I was about to ask
Yes.
on the same, but yeah, anyways, you are going to discuss this. Really great.
So you believe that, okay, important things I'll not cover. Yes. Okay. So no, I'll cover all the important things. Don't worry. Yes. So yes, it takes time, yeah, to cover all these things, give you the right example so that you understand it. But now you have some understanding of the basic concepts, basic object-oriented concepts. So let's dive into other concepts. So one is single responsibility principle, right? Let me now make it bigger also. Yes. So here, today I'm having trouble with this rule. Earlier it was easy for me. Yeah. So single, let me choose some other color. Yes, single responsibility principle. Okay, solid design. Yes. So what is single responsibility principle? Who will explain? Open, close.
Class should have only
Yeah.
one reason to change.
Absolutely. Nice, nice. Yes. So always model your classes such that you have single responsibility, right? It's easy to manage, easy to maintain if you have designs in this manner, right?
So as means single responsibility, right?
Yes, everything should have a single responsibility. That means if I have an employee class, I have everything around employee only. I should not have anything around functionality of the department or functionality of the project. Project class is the class which should deal with everything around projects. Such a common sense thing, actually. The department class should have everything around department. It has single responsibility. You should not have a class like employee who would have multiple responsibilities. I'll do this, or I'll do that. Because then that piece of code will become buggy. That will be very dynamic piece of code, and anything changes, you have to change here. And when you change something, there are chances that many other functionality gets broken, right? So you may say, okay, let's do everything in the employee class. We can do, no problem with that. But yes, then problem is, if you change employee class, it may happen that departments get broken or projects functionality get broken. You may get regression very easily. Another problem is, if many people are working in your team, everyone will be modifying the same class. When they will be checking in the code, there will be a lot of merge conflicts, right? And resolving merge conflicts is very big headache. So yeah, most of the time the teams will be resolving merge conflicts. So single responsibility principle is why they introduced it. It's very simple principle, but yes, they saw many people do not follow it, do not understand it. So that's why they emphasized it. So single responsibility principle is one of the principles.
But yeah, if there is
Yeah.
a like an employee class, we can have any number of functionality on employee related. I mean,
Right.
single responsibility doesn't impact. Obviously, we should not have all the features. But yeah,
Yes.
I mean, if you talk about in terms of single responsibility, if you are keeping even all the features related to employee,
Yes.
still it will be called as single responsibility.
Yes. So that means it should be related responsibility, right?
Right, right.
So yes, definitely. In employee, you would be having a functionality to update address. Maybe you have functionality to update the age, name, everything. So you have multiple functionality, but it is around the employee details. So then you can call it single responsibility, right? So maybe, yeah, always it's the case that maybe the CEO of organization, he has many a responsibility, but still you can call he has a single responsibility to take care of the company. Yeah. Or take care of, actually CEO takes care of the strategy of the company, that is single responsibility, right? But yes, you have directors, VPs, managers. So these people, they do a lot of things, but yeah, still they have a single responsibility, because singleness means related information, related responsibilities, not unrelated things. If you have unrelated things, then there is a problem, right? So now next thing is, don't go with the literal meaning. Yeah, it is sometimes difficult to give names to things, but yes, single responsibility means you should have similar responsibilities, which is all kind of related, and you can easily find what is where, right? Because otherwise it will be very difficult for you to find what is where. So microservices is a classic example. So if you don't understand these, when we'll be designing things, right, you will get used to it. So when we will doing microservices, you will see that yes, single responsibility principle is being applied again and again. So don't worry if you don't fully understand it, you won't be able to, because even big architects, experienced architects, they also do not understand many of these principles, because with practice only people build an understanding and it comes into their intuition. So now open close principles. Let's talk about open close principle. So what is open close principle? I'll give a classic example. Okay, this is an iPad. Okay, let me make it look like an iPad. Okay, this is an iPad. Yes, so we have some buttons here. Now we have maybe some more buttons. So this is a classic example of open close principle. Can anyone explain this? What is open close principle? And why I'm giving an example of an iPad for giving open close principle? Yeah.
A class should be open for extensions, but
Yes,
for
yes.
modifications.
Yes, right. Absolutely. Closed for modifications.
Yeah.
So let's say Apple, is it open or is it closed? Because yes, now I'm saying both the things together. You should be open for extension, closed for modification. Now I'll tell what is extension, what is modification.
So
right?
iPad can
Anything
be,
you can say, no, this is modification, this is extension.
yeah.
Yeah, go ahead.
So iPad can be, we cannot modify anything in the iPad, but we can extend it as a maybe laptop or something by extending using a keyboard along with it, something like that.
Right, right. So you have well-defined interfaces.
Yeah.
So you can extend using the interfaces, right? You can extend it by adding an app. Yes.
Yes.
But yes, you have limitations. You can't modify anything. You are only allowed to modify certain parts, and many parts are there which you are not allowed to modify. This is what is open closed principle.
Sorry, can you repeat again what is the open close principle you mentioned?
Okay.
You're saying that
You're making me repeat everything so many times, right?
no, basically
please help me. Someone else repeat. Yes. Yeah, it's good. No, I want you all guys to ask me repeat and repeat so that I can ask you other people to
Yeah, you mentioned few part can be modified, but few part cannot be modified. So I just want to
yes,
understand more on this.
Can someone share explain what they understood? Who would do that? Please feel free to speak, because communication skills very important in system design. To clear interview, you have to explain. Interviewer may also ask you multiple times, right? So you guys have to clear the interview. So who is going to explaining this open close principle? No one? Right. So any software, whether it's a class or a component, should follow open closed principle. The component or class should be extensible, right? Should be open for extensions. It should be closed for modifications. This is open closed principle. Example is iPad. They have some interfaces, right? So maybe you have Bluetooth, you have Wi-Fi. There are some mechanism through which you can interact and you can create some extensions, right? Maybe hardware extensions as well as software extensions. So in software, you may add apps. You can create apps. You may create app for n number of games, n number of applications, millions of apps you can create. But you cannot modify if you say, I want to change the resolution or I want to change the RAM size. That is not allowed in iPad. So it is closed for modification, but open for extension. So your software should also be like that. It should be open for extensions, closed for modification. So you should have a core piece, which is very stable piece that you do not allow to modify. And there should be places where you allow extensions. Now, why is it? Why not we say, okay, everything could be extended. Everything should be modified. Why there is open close principle? Anyone knows what is the reason behind that? Why Apple is not
Compatibility.
allowing? Huh?
Compatibility.
Okay, there could be business reason. Yeah, no, but throw away the business reason. Talk about only technical reasons.
Okay.
There's technical reasons also. Right? If you allow everything to be changed, then you allow for a lot of bugs, lot of problems. When you allow only certain things to be changed, you can ensure the stability of the system, right? So you can focus on something and users will also get best-in-class user experience, because otherwise you can standardize things and have a good experience to users. And at the same time, they want extensions also. So extensions also you can manage well, right? Because you have to always have focus, right? If you want to do everything, that's not possible. So you should know what you would like to allow others to change and what you don't want to change. So this is very important feature of object-oriented design also. You should identify that these are the things which are the core layer, which is not going to change going forward. But yes, some parts are going to change very frequently. Things which are likely to change very frequently. For example, apps. So when Steve Jobs designed Apple, he understood maybe the apps will change very frequently. But yes, the screen size, the RAM, there will be a lot of parts which will not change that frequently. So things that change very frequently, you keep it open so that you can gain the community or gain others to partner and enable that change. And things which are closed, which are not going to change, you can keep them stable. Right? This you should apply in any software. So this is, all these principles are done by, created by whom? Anyone knows? There is a person called Robert C. Martin. Search him over Google and YouTube. You'll find a lot of lectures. He's the one who coined this term, solid principle. And this comes in early 2000. So it's not very old principles. Let's move to the third principle. Third principle is,
open close principle in technical terms. Open is achieved using inheritance. Close means we should not modify the class, right?
closed is, yeah, closed for modifications.
Yeah. Then in technical terms, open is achieved using inheritance, and close we should not modify. We should not modify the existing class. That is
Yeah,
what, right?
open, repeat what you mean by open, what you said.
Open means here extensible, right? That is achieved by
Extensible, yes, absolutely.
achieved using inheritance.
Achieved using,
Inheritance.
okay, yeah, interfaces, yes, achieved using inheritance, correct. There could be multiple ways of achieving it.
And close means we should not modify the existing clause.
Yes, absolutely.
Okay. Thanks.
Yes, correct. Inheritance or interfaces are way of opening up the interface, correct. Basically, interfaces are the right term here. That opens up the class for extension, right? Inheritance, yeah, you can say, but I would say the interface part is mostly important here. And closeness is, anyway, you abstract, data hiding, encapsulation, everything is helping you to implement closeness, right? We'll cover that. Don't worry. There will be, when you will implement practically, there are multiple ways to implement it. So don't worry about the implementation, that you can ensure through any mechanism, but the principle is very important, right? Because in different languages, there could be different ways of implementing it. So there are many ways of implementing it, but yes, the concepts are common across all different kinds of languages. Even they are common across the granularity of the components. When you create a class, the concepts could be applied. When you create a package or a component or a module, same principles can be applied to the module level. When you create a big web service, a distributed application, same principles could be applied at a very high level also, right? So that's why I'm giving an example of iPad. iPad is the largest possible granularity, right, for a user experience which Apple gives. But yes, inside iPad, there are various hardware components. There are various software components, and in these software components also, they have applied open close principles. So yes, these principles can be applied at different levels. Now let's talk about the third principle. See, I'm getting the full form solid. Solid stand for SOL. L is Liskov substitution principle. What is it? Actually, you don't have to worry about this principle. This is sometimes coming for free for us. So it says objects of superclass should be replaceable with objects of subclass. So I'll move this. Oh, my iPad got broken. Now it got repaired. Yes, good. So, yes, objects of superclass should be replaceable with objects of subclass. This is Liskov substitution principle. Yes. Yeah, this is always there in case of Java, C#, Java, many languages, right? So you don't have to worry about it. But in some languages may not be possible. So then you have to implement it. Right? But yes, most of the languages I know, they support this. Let me move to the next principle, which is interface segregation principle.
On these things, can you please give the example? For example, what I'm understanding, let's suppose there is a class called hello, and there is a class called hi. Let's suppose you can take the imply and person. So person will be superclass. So is it something like superclass of imply? Is it something like person P equal to name imply?
For which you are talking about? Single replaceability?
Liskov substitution principle. Is
Object
it something
of
like
superclass should be replaceable by object of subclass. Yes.
so? How
Okay,
is there
yeah,
any
you need-
example or
yes,
something?
yes, I guess.
Yeah.
Nice question. Nice question. Perfect. Perfect. Yes. So shape, our classic example. You have a shape class.
Yes, circle class.
You have a square class.
Okay, yeah.
You have a relationship. Yeah, you may also have a circle class. Let's put
Anything.
a circle class also. There could be many subclasses, right? So all the subclasses should be able to replace the superclass. This is what the principle says. You have a method, or you have a, say, let's say there is a method called draw, okay, which takes an argument shape, right? So you have this method and you say draw. It's a void method because it draws something on the screen. And yeah, so I'm just putting here. So it takes an argument and shape, and whatever shape you enter here. So yeah, so you probably you have S, you say print here in this, some logic is there. So what it does is S dot draw, okay, and we say plus S dot assume name. Whatever is the name of that particular shape, it gets printed here, right? So draw, say assume this shape is called. So here, what it says that.
Here we can say that
yes,
yes
to
is
call
instance
this,
of yes is instance of circle, then it will print circle.
yeah, say star, new
Awesome.
shape, right? So this is, I may call here draw and pass a star, right? So what it will do is it will print here. Assume the name of star is pole star. So
I
here,
think the object creation should be different way.
right. So now what I can do is I can also pass here. Say I can say here shape S or S equal circle equal to new circle. See here also I am able to apply substitution
Right.
principle, right?
Right. So
I'm replacing the superclass
right.
with subclass.
Okay.
This was
Okay. I think you have written that because shape equal to new shape doesn't make any sense, right? I mean, it's just a parent class, and we don't have any idea whether it's a
yes.
circle
So that's
or
why
yeah.
it's available in Java, right? All Java
Obviously, yeah.
plus
Correct. So that's
Java.
what I was thinking about. That's what I was thinking about. As I was mentioning, right? Percent p equal to new imply something like that.
Yes.
So yeah, that's correct.
You have say draw this name of the circle is say we say red circle or whatever, right? So that got printed here, right? So this is what is the substitution principle. Yes, for and then for single responsibility principle, I already gave an example that probably you are a front-end engineer, back-end engineer, Java developer. We apply it in everywhere, single responsibility, right? Because if someone has many responsibilities, he will be having a lot of problems. He may not be efficient, right? So that's single responsibility principle. Single responsibility principle is logical concept. And then we are talking about, so we covered open close principle. So yes, in open close principle also I can give many examples. So iPad example I gave. Let's say we have a class called, let's give some example. Let's say we have a class called greetings, right? So assume you create a new application where you can say there's a New Year greeting class, right? So you can say message, you can give some messages. So here is string. You can say year or occasion, right? So this is again a void method. And you have here print method, right? So now in this method, let's say I have first string, which is happy, plus occasion, right? So yeah, now this greeting cards is a service which I'm offering. You can pass here in occasion, various occasions, which could be say Christmas, Diwali, right? New Year, whatever you want, you can pass. Right? So see, this is open to extension because occasion is something which is open to outside world to call. Right? Basically, it is a private public method. So it's available for other classes to call, and a lot of things they cannot modify. For example, here the happy part they cannot modify other people. When they call it in the runtime, I'm talking about runtime. This part they can pass on whatever they want, New Year, Diwali. So this is your extensions. This is a simplified example. You can make it more complicated or more thorough rather than complicated by saying that, okay, greeting class has an interface which it implements. And in this implementation, greeting class, I will just not use any parentheses here, implements, say, what is this message, right? So let's say I message interface. In this message, iMessage interface, I may define a method, this message. Right, so yes, that's don't put we don't put implementation here. So here, this is another level of extension. Whoever wants to implement something like this, he can implement iMessage and create his or own implementation. So assume you want, instead of happy, some other things to be done. So you can say class my greeting implements iMessage, and here you can say public void message string occasion. But yes, here instead of happy, you can say print, say welcome, or you can use some other greeting here. So best wishes, right, for occasion. Right, so this is another way to implement it. So here you see, you can extend it. So interface also provides a way to kind of implement open close principle. Here you are implementing extensibility of even the first part. But yes, this part is also modifiable. Right? But yes, maybe this is printing it in email. So you may define one class which is yes. Correct. See here, you may have a lot of logic here. Yes. So now this is an example of open close principle at various levels. I may have very much a lot of code for connecting to SMTP server. This is closed for modification. But what is open is I may pass best wishes for occasion. If I put here, if I pass here, say, assume this is my client. Okay, this is going to be in client. In this client is, suppose your main method. Okay, and you are calling here email sender, right? So assume you created this already a object and then say sender dot send. And then here you also created my greetings. Okay, so here greeting, or I message equal to new my greeting. Yes. See, everything is getting applied here. Polymorphism. Yes, sent. And here I am greeting. Right, so see here. This is your code. So a lot of things are applied here. This my capital. So your logic for connecting to SMTP server is something which is not going to change that frequently. But maybe greeting message you would like to have more and more. Here in this case, it will send best wishes for whatever is the occasion which is past, right? So this is your way of applying open closed principle. So in invoice, assume you are writing up software for building invoice. In that case also, you may have the template, a lot of things which cannot be modified, but a lot of things which can be modified.
Can you please scroll up the one which you have written?
Pardon?
Can you please scroll up?
Yeah.
From here, right. From interface, iMessage.
Yes.
Yeah. Just I missed to actually write that because I'm making note. So I'll just take this. Sorry to.
Yeah, I'll share all these examples. Don't worry.
Okay. All right. Yeah. Can you please scroll down once so that I can just make it? Yeah, that's it. Yeah, thank you. That.
Okay, awesome. So now next thing is ISP integrate segregation principle. So again, I will give here for anyone wants to share what is integrate, what is interface segregation principle of solid. This. I'll give an example here. Let's give something different example here. So interface segregation means an interface should contain methods which are related. It should not contain methods which are not related or which are not used by some classes. Correct? So let's talk about, there are multiple examples. Classic example is from the book. There is Head First book on design patterns. From there I'm giving, but they don't give this example, but they are explaining the same way I do. But yes, they are explaining other concepts, but this concept I will explain from that. So assume you have a class, which is, say, a duck class. Yes. So this class is called duck class. It has two interfaces. It has an interface. Suppose, which is, say, talkable interface. So talkable interface is nothing but it contains a method called say make sound, right? This is what the method it contains. You have another, there are various varieties of duck. You have, say, something called swan. You will have, which is also inheriting duck class, right? So swan is a duck. And if it wants to talk, yeah, but it does not talk, right? Swan does not make noise. So they will not implement talkable interface. But yes, maybe there is a duck which also talks. So that will implement talkable interface. But yes, there could be a toy duck also, right? So, but yes, most of the ducks fly, right? But some ducks don't fly. For example, toy duck cannot fly. So you will have to segregate another interface, which is flyable interface, right? Now you may argue that why not put both these methods? So here maybe we have a method called fly, right? So you may argue that why not have just one interface where you have both the methods, talkable and fly, right? Make sound and fly. But I would say that have separate interfaces, because swan is someone who will not talk, but will fly. And toy duck may make sound, but may not fly. Right? So now drones are there, so maybe some toy duck will also fly. But yes, I'm just thinking that yes, in case that is the case, so in toy duck you will implement this method, which is talkable. Yes, so yeah, I should move it here so that I can easily reassign it here rather than. So yeah. So this is my class diagram, and flyable is implemented by fly also, right? But yes, basically these are different. If you implement here and yeah, so yes, this is an example. So this is interface segregation. Is the principle it says that you should have methods which are segregated. It is sometimes most violated because if you have many methods in the interface, then the problem is you may not be able to, yeah, it's very similar to single responsibility. Yes, also correct. So Arun has shared this point. This is very simple to very similar to single responsibility pixel. Because if I put the definition, you will say that yes, this definition is also of single responsibility, right? So do not have fat interfaces in classes. Prefer having smaller interfaces with group of methods, each serving a particular purpose. This is the definition. And so now you will say, okay, this is nothing new. It's all what you have do. Then is rephrasing the same single responsibility principle. But yes, single responsibility principle is for classes. This is for interfaces. Basically, it is about single responsibility principle is about having responsibilities. This is one level further. It is about separating responsibilities with number of interfaces, right?
What is the fat interface actually?
Fat interface or large interface with lot of methods, right? Fat interfaces are interfaces with lots of methods. You would have seen a lot of libraries where you have interfaces with lot of methods. So these are fat interfaces.
Okay.
Right. So if I create an interface here and I call it IDuck interface and have both these methods, then this is a fat interface here. Still, you will say, okay, no, I can do with this. What I will do is I will implement here make sound. No, yeah, make sound. I will implement and I'll put a dummy implementation like this. And I'll say fly. Here you will have a lot of code, real implementation. So my Swan still will be able to use the duck IDuck interface. And toy duck here again, you have to put fly and with say override. This is overriding. Right. So and here fly will be having dummy implementation. But yeah, sound may make sound may have some implementation here. Could be print something, say. Well, right. So this is how your implementation. But yes, this is bad because you will have some people who will have to put a dummy implementation and which will lead to wrong code, lot of messy code and lengthy code. So this is all about interface segregation principle.
Okay, and the below which you have written shape, circle is square, square, and then mirror, right? These are the part of Liskov substitution principle, right?
What is the part of Liskov? Yeah, this circle and shape.
Yeah. That's what it's getting mixed.
Part of Liskov substitution.
I thought like it's getting mixed.
I'll be sharing notes. I'll separate it out, make it very clear.
Okay.
Maybe I'll share 5 different files where I'll have all these 5 principles separated in different files so that you don't miss out anything. So last principle, very simple principle, dependency inversion principle.
Sir,
Yes.
I have posted one doubt in the chat.
Okay, tell me.
Why we have segregation principle for interfaces, not for inheritance?
Segregate in interface segregation principle for?
We have segregation principle for interface, right?
Yeah, interface. That's why it's called interface segregation.
Yeah.
Yes. Yes.
Why there is no principle for inheritance? Like
why is there no principle for inheritance?
Yeah.
This Uncle Bob can answer. Robert C. Martin. Write to this guy. Robert C. Martin. Yeah, this is the name of the person who made this chapter. He is also popularly known as Uncle Bob. People call him Uncle Bob. I'll share his contact details. And probably, yeah, you can ask this guy. He felt that, yes, these are the set of principles.
Because inheritance and interfaces, like we extend, right? We implement, right?
Yes.
So both are similar.
Similar, yes, absolutely.
Segregation has to be there. Then we can, that same principle can be there for inheritance.
Yes.
But why only for interfaces? So that is my question.
Correct. Yes, yes. See, this is just a good set of guidelines. He has written a big book on clean code, which has guidelines around each and everything. Many guidelines, but yes, these are important guidelines. But yes, you are also right. Interface is anyway related to inheritance. So substitution, this is also inheritance, right? So when we talk about substitution, superclass, subclass, it is about inheritance. But yes, as such, this is just making things easy to understand for developers. So that's why they called it solid. And last principle which I will talk about is, we can keep discussing on these principles, and then whenever we'll be doing problem solving, we'll apply this. So next class, come prepared with the design of online chess application and apply these principles, because now we are over with all the principles in low level design. We can start now design patterns. And then after design patterns, I'll move to microservices and microservices design pattern. And yes, I have to cover sharding also. That also will cover with microservices. We'll cover sharding. So yes, let's talk about the last principle, which is dependency inversion principle. Right? This is an important principle. I'll give an example. You will see this in action very quickly. Let me get some classes. Yeah, this is enough. Classes. Let me get this. This is, let's say, a class which is, let's say, CEO class. No, but this should be. Yeah, so basically this is, yeah, about, this is not about exact inheritance. This is about I'm thinking of some good example. Yeah, let's say, yes, correct. But this example I'll continue. So here, let's say we have UI developer or front-end developer, right? We have back-end developer, various classes, right? And these are associated to because CO employs all these kind of employees, right? So in this, yeah, probably better word would be, let's say, secretary. This is a person who works for CO, secretary, right? This is, say, maybe advisor, right? Something. So these are the people who works for CO directly. So you see here in a CO class, you'll have a dependency, which is the direction of this dependency is this. Because here you will have for every secretary, and you will have an advisor, right? So basically, yeah, not this, the direction is this. So here what it says, this principle says is, rather than having the dependencies directly with the classes, if we have an interface or if we have another class, so let's say here you have a class consultant. Yes. And consultants both secretary and advisor. They are the consultants. Yes. So rather than having this dependency like this, you will have the dependency which will be like this. So we have inverted the dependency by having an intermediate here. So you don't have actually here separate entities.
So you are saying that arrow from CEO to consultant will be down.
Yes, yes. So we have inverted the dependency. So this is good because now you can keep adding. The CEO may have more kind of employees. Suppose a new kind of employee comes, which is, say, legal advisor. Since this guy is also a consultant, you don't have to modify anything here. Right? So that's the advantage of this principle, which is dependency inversion principle. So basically what we are saying here, it's no, don't go by the name. I prefer it calling, rather than having too many dependencies, have less dependencies. So earlier what I would have to do, I would have to do one more dependency. I would have this dependency. I would have this dependency. Now, instead of all this, I have this dependency, which is legal advisor is a consultant, right? But I don't have these dependencies, right? So this is what is called dependency inversion principle.
Tarun,
Yes.
how the dependency is inverted? Still, the consultant should depend on the CEO, right?
Yes.
CEO is
Right.
dependent on
Yeah.
consultant.
Correct. Correct. So this part is inverted. Actually, yeah, this rather than, yeah, this new class is there. So it's not actually inverted. Yeah, only this opposite arrow came here, right? Which was not there earlier.
So we have used a substitution principle also over here.
Yes, here you have used substitution principle also. Absolutely right. Yes, but yes, this principle focuses on
You haven't changed
basically less number of dependencies.
the consultant to CEO, right? Like it's still
Yes,
down.
there's only one dependency now rather than 4 or 5 dependencies.
No, my doubt is the arrow should move from consultant to CEO or CEO to consultant.
Yeah, it was same direction. There was no change in the direction of the arrows. Yeah, it was
Oh, okay.
initially I thought, yeah, maybe the dependency, it's called dependency inversion, so it would be inverting the dependency, but it is not. Dependency is in the same direction still. Yeah, you can't invert the dependency always.
So
Let
is
me,
it
yeah,
like dependency injection itself, right?
that is a different principle.
Okay. Okay.
This is nothing to do with dependency injection. Dependency injection is called inversion of control. But inversion of control and dependency inversion is again two separate principles, right? They are not part of solid principle. So don't confuse it with inversion of control or dependency injection. This is dependency inversion. Right? So yeah, this is, you are right, absolutely right. This is substitution principle. This says that this consultant, all these will depend on consultant, legal advisor, secretary advisor. So yeah, here the arrow direction has changed. So that is what they signify by inversion, dependency inversion, right? So if you see from this perspective, from CEO perspective, there's no change in the direction. But if you see from legal advisor's perspective, for perspective of all these classes below, yeah, this classes below, there has been inversion of dependency direction. So that's why it's called dependency inversion. Got it? Because for these classes, the dependency direction has become inverted. But yes, we don't worry about that. More important principle here is that rather than depending on too many dependencies, we should abstract things. So this is about abstraction also. Consultant is abstraction of all other kinds of employees, which is legal advisor, security secretary, and maybe this is technical advisor. So for CEO, it's all employees, so it's abstracted. And here the implementation is simplified. Because for the implementation, it does not make sense to have more details. So this is abstraction as well. And it says that rather than depending on multiple dependencies, better to depend on a higher level dependency. And this is also we use in designing software in layers. We always have multi-layer architecture. Layers are nothing but layers are also called layers of abstraction. Right? So this is all about solid principles. I'll share you detailed references so that you can practice it. And when we will be covering more low-level design exercises, we'll be learning this. So you will become master of all these concepts. We'll cover a lot of other exercises in this low-level design. So we will game design, we are already in the middle of. We'll continue doing that. What other designs which we will be doing is we'll be working on elevator. We will be doing book my show. We will be doing a lot of other some more exercises we will do. So low level design. So these two things, 2-3 exercises, we will do one more, which is design of a parking lot. Okay, parking lot, library management system. And when we will visit all these design, these 4 and 5, overall 5 I was planning to do in low level design. Because after doing this 5, which is the chess, which we are already doing, after doing this 5, you will be master of all the low level design concepts. And we will also cover design patterns. And we'll see how we can apply all these in these.
We covered design patterns while solving the problem. Or separately?
We will cover design patterns also. Because they are very important topic and they should be known to all the developers while giving low level design questions. Okay. So I have a request. Someone got a question about low level design of Redis. So we'll cover that. Redis is a caching system. We can cover that also. Okay, let me add this also there. LRU cache. Basically, the same question could be asked in multiple ways.
Yeah. Okay.
Right? Design a LRU cache. Here you have to go into the data structure. Think about what data structure will you use. I already covered low-level design of indexing. If someone asks you what is the low-level design of indexes, database indexes, right? So we know that it's B plus tree. Why it is B plus tree, we also know. But yes, maybe you have to implement it by yourself. Learn the algorithm for insertion, deletion, updation.
We use a hash tables kind of data structure.
Yes, nice.
Yeah.
Correct. But hash table will not help
Okay.
because you have to also get the last in, first out.
Okay.
Least recently used.
Please.
Right? So how will you get in hash map? Do not store which is the least recently used item.
Yeah.
Right? So think about it. We'll discuss it in coming classes. So you guys should do a lot of problem solving, because if I'm solving problems, I'm just getting better in system design. You guys are not getting better in system design. So the goal is you guys should get better. I should be able to help you out in improving your skills, because what is happening otherwise, until unless you don't practically try it, you will not learn. Because also important, as I said, thought process and approach is important rather than the final solution. And you need to convince the interviewer that this is the best design. No design is best. There could be multiple right answers for system design questions. But yes, if you are able to convince, it's the right answer. If you are not able to convince, maybe your design is very good. Still, your answer will not be considered right. So practice. Keep practicing every day some design problem, and we should discuss in the class mostly your questions rather than I teaching you some concept. So by Thursday, complete the system design of chess, and we should discuss chess design, system design. So of chess in the next class. Maybe implement the chess. I would say in 8 hours, you can build a chess game, which we can play during the class. So best thing is if we can play the chess game in the class, which you have designed, that would be the awesome. But yes, at least try implementing the design. Try building the design. Implementation you can always do in some other day. Since your focus should be now on understanding the concepts. So ensure while designing, you are applying all the concepts, and we can discuss on the design on Thursday, and then we will start design patterns as well. Okay, great. So good night, all of you. See you on Thursday.
Thank you.
Great, great. So awesome. So we'll cover again in case there are some doubts on the Thursday class.